Good day guys, this is your tutor engineer. Today we are continuing with our series on motion on one dimension. We'll be focusing on graphs and motion. So let's start with today's lesson. A girl jogs at 5.4 kilometers per hour for 5 minutes in a westerly direction. Draw the position time, velocity time, and acceleration time graphs for her motion. Clearly label the axis and indicate relevant values on the axis. Okay, so we've been given a velocity, right? That's the first thing we've been given in kilometers per hour, and then we've been given time in minutes. So let's start by plotting the velocity time graph. This will be the time axis, and then this will be the velocity. So let's just start by converting. It's easier if you convert the velocity to meters per second. We're given 5.4 kilometers per hour. In order to convert it, that means we need to multiply it by 1000 meters, since there are 1000 meters in a kilometer. Then you divide by the time would be 60. 60 is to convert to minutes, and then another 60 would convert our time from hours to seconds. So let's divide that by 1. So basically you're having 5.4 divided by 1 multiplied by 1000 divided by 3600. So this will work out as 5.4 times 1000 divided by 3600. It's going to be 1.5 meters per second. Okay, we're going west in the original direction of the girl's motion. Okay, so we can do likewise with the time. 5 minutes, we can convert 5 minutes to seconds. That would be 5 times 60. It will give us 300 seconds. Now let's come and plot on the time axis. To accommodate the 300 seconds, we can just say here it's 100, 200, then 300. And then to accommodate the velocity of 1.5, we can choose the scale of 0.5. Here it will be 1, and then there it will be 1.5. Excuse me. And then let's plot the velocity time graph. It's going to be a constant velocity, since the girl will be jogging at 1.5 meters per second constantly for 300 seconds, right? So let's just project this to 300 seconds. So this will be the velocity time graph. And then let's go to plot the position time graph. Okay, we'll use the velocity time graph for a position time graph. So time axis, and then here the position would be change in x in meters axis. And then, as we've spoken about before, if you are given the velocity time graph and you need to work out the position time graph in meters, that means you need to calculate the area under the velocity time graph. So likewise, if you have to work out the acceleration in meter per square second, that means you need to work out the slope of the velocity time graph, then it will give you the acceleration. So for now, let's focus on the displacement or the position by working out the area. So the area under the velocity time graph is the hatched part, which has the base of 300 seconds and the height is 1.5 meters per second. So we can easily work out the position by saying the position is equal to base times height. Since it's the area of a rectangle, our base is 300, our height is 1.5 meters per second. So this will give us a position of 300 times 1.5, which is 450 meters towards the west. Okay, now let's plot this part of the position time graph on our system of axes. So the time will remain the same. So let's plot here on the position axis to accommodate the 450. We can just say, okay, let's choose a scale of hundreds. Here it will be 200, 300, 400, and then there about 500. Okay, 500. And then, okay, the 450 will be somewhere there. Okay, let's make our graph a little bit prettier. Okay, so 450, it's there between 400 and 500. So the position from the velocity time graph will start from 0, and then it will go up to 450 after it has reached, after the girl has reached 300 seconds. So it will look something like that, a straight line. So a straight line will be going until 450. Then you can just project that to 300 seconds. So that will be our position time graph. And then let's plot our acceleration time graph. Okay, you'll be having a time here in seconds. Our acceleration unit is meter per square second. And then, okay, always our time will remain the same. This will be our time. And then let's work out the acceleration. Remember, since you already have the velocity time graph, we know that in order to work out their acceleration, you need the slope of the velocity time graph. Then you would have had your acceleration. Okay, let's just make and mark the coordinates here. The coordinate is 300 seconds and 1.5, and there the coordinate is 0 and 1.5. So let's work out the slope and then we'll have the acceleration. So we'll call this time 2. This we'll call v2. This one is time 1 and v1, right? So let's work out the slope. So we'll say v2 minus v1 time 2 minus time 1. That means the velocity stays the same. v2 and v1 is going to be the same value. And then after 300 seconds, that's time 2. And then the girl started at 0, so time 1 will be 0. So here we'll have 0 divided by 300, which will give us 0 meter per square second. So our acceleration is 0. Let's plot it, even though one may not see a need to plot it, but let's just demonstrate that we understand that the acceleration would be 0. The girl won't be accelerating for 300 seconds. You can just write there. That's the acceleration. Okay, we've come to the end of our part A, actually, on the position time, velocity time, and acceleration time graphs. I'll be doing part B on the next lesson, where I'll be solving a problem, having been given the acceleration and being required to work out the velocity time graph and the displacement time graph. Please stay tuned for that lesson. If you liked today's lesson, please subscribe, and I'll meet you again on the next lesson. Cheers.